Hello, this lesson is on slope fields. So I know this chapter, the students been a little bit of a mix of different topics, different things. We've done derivatives of e, of ln, of inverse functions, inverse trig functions. Now, slope fields. What is slope fields? I think slope fields is probably one of the easier topics in calculus because there's not very much math. There's not so much adding, subtracting that you're doing. The basic definition of a slope field, as you can see, it's a graphical representation of a general solution to a differential equation with different c values. So if you remember in our last, one of the last sections that we talked about solving differential equations, this is how the graph looks like. So here's an example of a problem. It says, draw a slope field for dy dx equals negative x over y. So if you remember in the past, what we would do is we'd cross multiply, we'd take the antiderivative of both sides, etc. But what if I want to graph the general solution? So what I do is I take a point. So let's start with 0, 0. I plug that into my differential equation and draw the slope in which I, the slope that I get. So if I plug 0, 0 into this right here, negative x over y, I'm going to get indefinite or undefined because you can't divide by 0. That means a vertical line. So I'll draw a vertical line there. And then in my table, let me draw 0, 0, and then I'll just write for undefined. Okay? Or it means infinity. How about that? Let me draw that instead. Infinity. Okay, because you're dividing by 0. Now let's try going up. So this is the point 0, 1. So I'm going to write the point 0, 1. Now if I plug 0 into my formula, I get negative 0 over 1, which is 0. If I go here to 0, 2, I will also get 0 divided by 2, which is also 0. If I do 0, negative 1, and I guess you guys can see the pattern, that if I did this for all the ones on this y-axis, I would get this. By the same token, you'll notice that if I did everything on the x-axis, if I did this point right here, 1, 0, I get 1 divided by 0, which is undefined, or infinity, because you can't divide by 0. And you'll get the same thing for all of these. You don't have to fill out the table. Okay, so I think you guys can figure that out. Now, let's talk about this line right here. And you can start wherever you want. I'm just randomly picking a line. Let's do this one. This one is 1, 1, and this is 1, 2. So let's try 1, 1, and 1, 2. If I plug in 1, 1, I get 1 divided by 1, and I have a negative out in front. So the answer is negative 1. To draw a slope of negative 1, you basically draw a line that has a slope of negative 1. So I'm going to draw that. At 1, 2, I'm going to get negative half. So I'm going to draw, again, a slope of negative half. It's like not as steep as negative 1. So I need to draw a line that is kind of negative half. Okay. At the bottom here, I have negative 1. I have 1, negative 1. And if I plug in 1, negative 1, I get a positive 1. So this is going to be a positive 1. And if I plug in 1, negative 2, I'm going to get a positive half. So again, same thing. I'm going to draw a slope that's kind of like a half. And you don't have to be exact. You just kind of have to see how it looks like. For sake of time, let me do this line right here. This line, I'm going to do negative 1, 2. And if I do that, if I plug in negative 1, 2 into here, I'm going to get 1 half. So it looks like that. If I plug in negative 1, 1, I'm going to get 1. So it looks like that. And just for, I think some of you can see the pattern here, what this is going to look like is, like so. You can see it's kind of like, as a circular pattern. And you can do this for the other dots. You just need to draw a slope field. And that's your answer. That's what a slope field is. And if I do more, like if I want to see more, again, I could do more. This is negative 2, negative 2. I'm going to get negative 2 over negative 2. I'm going to get negative 1. If I do negative 2, 1. Oh, sorry. This is negative 2, positive 2. Okay, so negative 2, positive 2. Sorry, negative 2, positive 2, I'm going to get a positive 1. And if I do negative 2, positive 1, I'm going to get 2. So a steeper one, like so. And you'll notice that there is a pattern. In slope fields, there's always a pattern. You just have to try to figure it out. But it looks something like that. Okay, that's a slope field. That's how you do your answer. Then the question asks at the bottom, it says, describe for where all the points where all the slopes are positive. Well, you notice that all my positive points are here, right? And down here, all my positive slopes are in the second and fourth quadrants. And sometimes it's not like that. Sometimes it's not going to be just a quadrant. Sometimes it's going to be like a group. You just have to explain which groups are. When the question says which ones are negative, same thing. I know these are negative, and I also know these are negative. So let me write down quadrant 1 and quadrant 3. Then it says describe where we have a horizontal tangent line. You'll notice that my horizontal lines are here on the y-axis, except for 0, 0. See, horizontal, horizontal, horizontal. So I'll put all on y-axis except 0, 0. Okay, and then all those that have a vertical tangent line, all those on the x-axis. So that's how you do these type of problems. Not so bad. Now, here we go again doing equations of tangent lines. So this last problem says, can you draw, or can you give me the particular solution with the initial condition of this, and then write the equation for the tangent line. Alright, so this is something you've done before. Again, I have dy dx, which is given to me, equals negative x over y. And if you forgot where we got that from, again, it's right here. They give us the equation, the differential equation up here. This one, I'm just learning how to graph it, so I graphed it. But now they want to know what the particular solution is if I have this initial condition. So if you remember, I cross-multiplied like so. Then I took the antiderivative of both sides. Then I solved it. This is going to be half y squared equals negative half x squared plus c. Then I solve for c by using my initial condition. So everywhere I see x, I'm going to put negative 2. Everywhere I see y, I'm going to put in 1. So this becomes half. This one, negative 2 squared is 4. 4 divided by negative 2 is negative 2 plus c. So if I add to both sides, I'm going to get like 2.5 or 5 over 2. Okay. Now the problem is that it asks for the equation of the tangent line. We'll talk about it in classes. It's kind of complicated, so don't worry about the equation of the line. So right now, all I did was solve for the particular solution. If you go to your page, we'll do more of these in class. Again, I don't want to make the videos too long, but I want to do a different variety of questions that maybe you're not used to. So say, for example, let's look at this one. This one, they gave you a slope field already. Here's the differential equation. As you can tell, this is not a very fun or very easy or one that you want to do, that you want to solve. So they give you the curve for you. And it says, sketch the solution curve that passes through the point at negative 1, 1. So basically what you're finding is a whole bunch of solution curves, depending on what your initial condition is. This one they want to say, give me the solution curve that passes through negative 1, 1. To do these type of problems, you need to navigate and find where is negative 1, 1. So here's negative 1, 1, and I'm going to draw a big dot to show you where it's located. Now, all you have to do is think of this as like a river. So these are like currents that are basically blowing. Like if I threw, basically what you're doing is, what if I threw a piece of trash right here? Like, where would it flow in this river? So to draw a solution curve, all you do, like I'll start from the dot and go towards the left. If I was going to go towards the left, if the current was blowing this way, where would my dot go? Well, my dot would go a little bit here, a little bit here, a little bit here, and then it would like go up like so, right? Because you can see the current go curve up. On the right, again, I'm just going to ride this current. It looks like it's going this way, then it looks like it's going down, and then it's going back up like so. Doesn't have to be exact. Again, you're just following the current. I think it's, again, very easy, and that's how you do that. Here's another example. This one says at negative 1, 2, so at negative 1, negative 2, I draw my dot. You could go anywhere first, so let me start at the right. Again, I just follow the curve, and it goes kind of straight up like that. On the left side, same thing, but maybe a little bit steeper, like so. And that's how you find for a solution curve given a slope field already. And the last type of question that they could ask you for the AP exam, is that the last one? Yeah. Last one they could do is, instead of making you make a slope field, they'll give you 4 different options, and they say, hey, which one of these is which one of these functions, A, B, C, or D, or whatever. And again, for sake of time, I don't want to waste your time. I'll just tell you the process. But essentially what you're going to do, one of the things that you could do is you could take A and make a slope field and see which one it matches. Another thing you could do to be smart, like if you don't want to waste time on the AP exam, is find a point where it's different on all 4 graphs. So for example, and they have to be very, very different. For example, look at 1, 1. See at 1, 1 I have this flat line. Here I also have a flat line. 1, 1 is not a good number to test because it's the same in 2 different functions. I need to find something that's different for all of them. What about, again, this is hard for me to figure out one that has all, or I don't know, wait, how's this? Let's try 0, 0. 0, 0 is very nice because it's a small number, it's a very easy number. Look at 0, 0. Here it's a negative slope. If I plug in 0, 0. Here if I plug in 0, 0, I get a vertical line. Here if I plug in 0, 0, I get a 0 slope, and here I get a 0 slope. So if I plug in 0, 0 and I get 0, it might be one of these. If I plug in 0, 0, it might be one of these. So let's try A. If I plug in 0, 0, I get negative 1 over 0, which means I have a slope of undefined or infinity, which is, on the slope field, a vertical line. If I look at my 4 0, 0s, this is not a vertical line. This is not a vertical line. This is not a vertical line. So A has to have a slope field that is equivalent to number 3. So that's all the time. Again, I don't want to waste all your time talking about slope fields. I think they're very simple. We'll practice more like you had requested. I'll go over it more in class. Hope you enjoyed the video, and I'll see y'all. I'll see you all in class. And if you have any questions, make sure you put it in the questions if you have anything. Also, just to remind you, if you have any questions, you need to tell me specifically where you're confused. Don't tell me I'm confused on everything or I don't understand it all. Like, there has to be some point, whether it's the beginning, whether it's the middle, you could see, like, these are small, easy steps. So tell me the step where you get confused, and I'll help you out. So have a good weekend, or have a good night, and I'll see y'all when I see y'all.